Welcome to the presentation of NamaTreasure, Playing with Your Children Programming, a book that will help you with 8 steps to learn and practice programming with your children. We have finished the introduction and now we go to the chapter 1. Now, we claim that if you can communicate, you can program. Because programming is like a language. So if you can communicate in any language, you can learn programming. Programming is like writing instructions with simple sentences. Well, maybe you have learned that computers understand 1 and zeros with complicated symbols and curly brackets, that like they have in third generation programming languages, and many other symbols that are scary in the beginning. However, programming has evolved, and now we're in the 5th generation languages, and for children we have these languages which is made out of commands that you can drag and drop, put the one under the other. There's only one way that they can fit together, so a lot of correction is done by the way the commands are designed to fit one another. Moreover, like we have 1 and zeros in the computer, we have neurons in our brains and electric pulses, but nobody cares about that. The same way we don't care about 1 and zeros in the computer, because we communicate in a higher level and we program in a higher level also. Computer program is a set of simple instructions, much like giving instructions to someone how to go to a certain place or to cook a recipe. And these are some instructions like move 1 cell right, move 2 cells up, and so on. In programming, there's a lot of repetition, but computers don't mind repetition. So we can use the same sentence structures over and over again, and we don't have to change the way that we write one sentence to look nice. We can use the same structure that it is certain that it conveys one meaning, and we don't like to change the way we write or use different words. For example, we have instructions like move 5 steps forward, move 4 steps up. And from these examples, we go in generals and we say move, number of steps, direction. Move, number of steps, direction is a sentence structure. We replace number of and direction, and we create many other sentences. For example, we have turn right, turn left. The sentence structure is called turn direction, and we can have all the directions. Moreover, we can combine these symbol instructions, like move 1 step forward, turn left, move 2 steps forward. We combine them in a new command, like that we say it's move horse. So from now on, we created a new word called move horse, and this does 1 step, turn right, turn left, and 2 steps up. So it's like the move of a horse in a chess game. Now this is magic. Yes, there is magic in programming. It is magic because we have created a new word. And a new word is like going to an abstraction level and then going to another abstraction level, and we go higher and higher levels of abstraction, like we have the languages that we speak. And if we go to very high levels, we may end up to not being precise. bad in computers because we defined how the low level is. So it's like every time you use a word in our everyday conversation, if all we knew the same definition, it wouldn't be a problem. In computers, they have the same definition for their words that we use. In computers, we have immediate feedback. It's like playing the piano. The moment you touch the keyboard, you can listen to the music. It's the same in programming. The moment you do something, you can watch the result, and this way it can help you fix your mistakes as soon as they are created, because mistakes always happen, and the important thing is to try again and again until you get it right. So writing a program is like doing a painting, like you see all the time, and you get an idea of how it's coming about. It's like carving a stone. It's like being a sculptor. Programming is done, and you continually see what has been done. Programming is a logical plan. You have to be able to separate the program into small pieces, like assembling this robot from small pieces, and you put them all together, and there's one way to put them all together, and you get this result. This is exactly what programming is. And these small pieces is recipes that you can learn by practice and practice and practice. And in the end, you will end up having all these kind of tools and pieces in your mind. And every time you want to make a program, you can draw them out of your mind and put them together. And then you have a virtual robot in your mind. And then it goes out to be programmed into one computer or something like that. Programming is separated into three phases. First, you select the ingredients. So it's like set up. You have to set up the environment. Then you do the instructions. You do the instructions all over again. And then somewhere in here, you test. You do something, you test. You do, you test. You do, you test. And then if it is cooked, you do something else. This is programming. It's a loop, and you do something. If something happens, you do something else, and so on and so on. So you define behaviors, you define something to do, and programming is mainly a loop, cooking, a test, and then if the test is correct, you do something. If not, you do something else. Now, programming is done in programming environments. Like we have games, chess game, backgammon game, card games. The same in programming, we have programming environments. And this is the programming environment called NamaTreasure, which is a game that it's about someone hiding a treasure, writing the instructions that look very similar to the programming instructions, the programming language, and then somebody else tries to find the treasure. We also have the Scratch environment, which is made out of by MIT. It is based on other efforts like Agent Sheets, eToys, has built on many other platforms, and it's one of the best platforms now because it is a balance between ease of use and the ability to do something very nice and the ability to share it on the internet. And it's extremely good for beginners. Now the language that we have seen in Scratch, like these blocks that they fit together, you can also find it in the Blockly, which is made out of by Google. And these Blockly games, it's a very nice way to test the level that you are in. It's a small piecewise levels that you can put together, and then if you finish and you come to this point, you are a programmer that know all the basic structures of programming, and you can go in very small steps. So we have Scratch, we have NamaTreasure. Programming is a continuous loop of, it's like cooking. We have to find the ingredients. Programming is like putting a lot of blocks together. In programming, we have immediate feedback. In programming, we have magic because we create new words. to create a new whole vocabulary, and programming simple sentences that we can combine and make more advanced sentences, structures. Computers don't mind repetitions, so you don't have to invent new words all the time. Computers is like giving instructions to someone. Yes, although our brain works with neurons and electric pulses, still nobody knows about them. The same computer works with one and zeros, but nobody cares about them. And last, if you can communicate, you can program. Thank you very much for watching this presentation, and you can buy this book. You can start tomorrow, learn it and teach your children and practice programming so that your children create a lot of recipes in their mind and they can solve any programming problem. Thank you very much.